Hi students, my name is Dr. Marie Wong. In this short video, I'm going to show you how to do hand calculations for a chi-squared test of independence, and I'm also going to show you what the SPSS output would look like for that same data that we used for the hand calculations. So to get started, we need to first talk about our hypotheses. Our null hypothesis is that the two variables are independent, that no relationship exists between them. The research hypothesis is that there is a relationship between the two variables. Now, if you recall, to test our null hypotheses, when we're doing hand calculations, we need to have a critical value. And what we're going to do is we can find the critical value in a chi-squared table. You can find those in the back of stats books, or you can go online and find a chi-squared table. And to look up a critical value in the chi-squared table, we need two things. We need to know degrees of freedom, and we need to know our alpha level. Our alpha level, we're going to set at 0.05. We just do that typically in psychology. That's our conventional alpha level that we use, 0.05. For degrees of freedom, I haven't shown you the example that we're using yet, but basically it's going to be, it's a table that has 2 rows and 2 columns, okay? So all you need to do is know the number of rows and number of columns you have in your data table to figure out degrees of freedom. So in this case, because I have 2 columns and 2 rows, my degrees of freedom are going to be 2 minus 1 times 2 minus 1, which is 1 times 1 equals 1. So for this particular data set that I have, degrees of freedom are going to be 1, and alpha is at 0.05. So if you were to look that up in the chi-square table, you would get a critical value of 3.84. That critical value is the value that we're going to compare our chi-square statistic with. We're going to calculate chi-square, and we'll get a chi-square statistic. We'll compare that statistic, that number, with this critical value. If our chi-square statistic exceeds this critical value, then we can reject our null hypotheses. Okay, so now on the next slide, I want to show you how to calculate expected frequencies. If you recall, chi-square, when we do a chi-square, we're comparing observed frequencies and expected frequencies. Now, the observed frequencies, those are frequencies that are coming from our data set. So if you look at the table on the left, what you'll see there is I have personality, type A and type B, and heart issue, yes or no. Personality type A's, those people tend to be very competitive. They have a sense of time urgency. They're people who are just a little more competitive. Type B people tend to be more laid back. And then, of course, so we're going to look at everybody in terms of type A, type B, and if they have a heart issue or not. What you can see is I have 4 cells. One cell is type A. Yes, they have a heart issue. 25 people are in that particular cell. Type B, having a heart issue, 10 people are in that cell. For being type A and not having a heart issue, 5 people are in that cell. And then finally, for being type B and not having a heart issue, 40 people are in that cell. Those are what are known as my observed frequencies. That's my data. What I want you to also pay attention to, 2 other things. My sample size is 80. To get my sample size, I can just add up those 4 cells. The 25 plus 10 plus 40 plus 5, the numbers in those 4 cells should equal 80. What I have in red, we're going to use row totals and column totals to calculate expected frequency. So I have those in red. A row total is simply, we're just going to count across the row. So for example, for people who have a heart condition, that row total is 35. I just took the 25 and the 10 in that row, and that's how I got the 35. Same with people who don't have a heart condition. There's 5 and then there's 40, so my row total is 45. Same thing for the column totals. For people who are type A, I just take the 25 plus the 5, and that's where the 30 comes from. For people who are type B, I take the 10 plus the 40, and that's where the 50 comes from. So you're going to need to know the row and the column totals in order to calculate expected frequency. And once you know that, it's easy to calculate. So for example, for type A, people who have a heart issue, what we're going to do is we're going to take the column total times the row total and divide by n, our sample size. So to do that, for type A, the column total is 30. For yes, having a heart issue, the row total is 35. So that's where you can see, if you look at my expected frequencies when I'm calculating it, if you look at the cell for type A, yes, you'll see 30 times 35 divided by 80 equals 13.12. That's my expected frequency for the cell type A, yes. All right, so let's do one more to make sure you're clear on this. For type B, yes. What I'm going to do, again, I'm going to take my column total times my row total. The column total for type B is 50. The row total for having a heart issue is 35. So 50 times 35 divided by 80, that gives me 21.88. That's going to be my expected value for that cell type B, yes, having a heart issue. Same thing for the other categories. So the other cells. So for type A, no. Again, I just take the column total times the row total, 30 times 45 divided by 80 gives me 16.88. And then finally for the last category, type B, no, that's 50 times 45 divided by 80 is 28.12. So what I've done is I've taken my observed frequencies and then using the row and the column totals and my total sample size, I've been able to calculate expected frequencies. And you know with chi-square, what we're doing is we're comparing observed and expected frequencies. I did put this in a table here to make it a little easier for you to keep track of the different values. You have to make sure that they match up, that the observed value and the expected value are from the same cell. So you need to make sure that those cells are matching up. So that's why I made this table here. I also am just reminding you of what the formula for chi-square looks like, where we're taking sigma, and then we're taking the observed value minus the expected value. We're going to square that, and then we're going to divide by our expected value. So we're going to do that. We're going to get to our hand calculations, and I'll show you how to do that in those hand calculations. All right, so hand calculations here. I'm just going to write the chi-squared formula up here again, just to make sure you don't lose track of what we're doing. So for each of our cells, we're going to take the observed frequency minus the expected frequency, put that in parentheses, square it, and then we divide by our expected frequency. Okay, so what we're going to do is let's start with we have 4 cells, right? So we're going to do this 4 times. So one of our cells, the observed frequency is 25. The expected frequency is 13.12. Put that in parentheses, square it, and then we'll divide by 13.12. Okay, so that's my first cell. My next cell, observed frequency is 10. Expected frequency is 28.88. Put that in parentheses and square it. Divide by 21.88. For my next cell, it's going to be, that one was 5. That was the observed. Minus 16.88 is my expected frequency. Put it in parentheses and square it. Divide by my expected frequency, which is 16.88. And then finally for my last cell, 40 minus 28.12. Parentheses squared, and we're going to divide by 28.12, which is my expected frequency. Okay, so those are I had 4 cells, and in each cell, again, 25, that was the observed frequency for type A, having a heart condition, and then I have my expected frequencies plugged in there. The next cell was for type B, having a heart issue. That was 10 was my observed frequency, 21.88 was my expected frequency. The next cell was type A, no heart issue. That was where the 5 came from. The expected frequency there is 16.88. And then finally for my last cell, that was type B with no heart issue. That observed frequency was 40. The expected frequency was 28.12. All right, so what we're going to do is we just do our math for each of these. 10.76 plus 6.45 plus 8.36 plus 5.02. Okay, so those are the things that I'm going to add up. And so when I add 10.76 plus 6.45 plus 8.36 plus 5.02, what I end up with is a chi-squared of 30.59. So this is my chi-square, 30.59. And if you recall, our critical value, when we had looked this up in the table, was 3.84. Okay, because my chi-square is bigger than my critical value, my 30.59 is much bigger than my critical value of 3.84. I can reject my null hypotheses. I can draw you sort of a quick sketch of this. So let's say this is the chi-square distribution, and here's my critical value of 3.84. Anything out here in this shaded area, in the tail area, would be where we would reject our null hypotheses. Clearly, our chi-squared of 30.59 is going to be way out here, so we can reject the null. So what we're saying when we reject our null hypotheses is that we do not think that personality type and a heart issue are independent. We think that these variables are actually related to each other, that there's some sort of relationship there. So now I just want to briefly show you some SPSS output, what it would look like if we took this same data and we put it into SPSS and we did a chi-square test of independence. So when we do this, here's the output that you would get. So if you notice at the top, that table you see, personality type by heart issue, it says cross tabulation. That's the frequency table that we started out with. That looks pretty much like the same thing that we have in the PowerPoint slides there, right? Where you're seeing it's a table, it has 4 cells, you can see the row totals and the column totals, and so on. Then if you skip down, you can see that the chi-squared number that you're getting is 30.56. That's pretty close. Ours was 30.59 when we did our hand calculations. This is 30.56. Degrees of freedom are 1. We had calculated that before. And notice our significance level is 0.000. If you recall, when our significance level is less than 0.05, that is when we would reject our null hypotheses. So in this case, we do have a statistically significant difference. We have rejected our null hypotheses, and you can see from this output that we got the same results that we got when we calculated this by hand. I also just wanted to show you at the end here an effect size. So in many of our statistics, we should present effect sizes, and an effect size tells us how strong the effect is. With the chi-squared, when you do a test of independence, it produces an effect size, so phi 0.618 or Kramer's V 0.618. Those are just measures of effect size. And I just want to make you aware of effect sizes. And the way that you would interpret these effect sizes, this is basically like the proportion of variance in one variable explained by the other variable. It's in terms of variance accounted for. So again, just wanted to mention briefly that whenever we reject our null hypotheses, we often also want to look at effect sizes. That tells us how strong the effect is that we're looking at, how strong the effect of one variable is on the other variable. So in this mini lecture, what I did was I showed you how to hand calculate a chi-squared test of independence, and then I just walked you quickly through what the SPSS output would look like. Thank you.